So in this lesson, we will focus our attention on Cramer's rule. That's one concept we'll be talking about. The next thing we'll be talking about is adjoint matrix, adjoint of A. Some people call it adjugate or adjoint. We write ADZ in short. And then we will learn how to use determinant to find the area of a parallelogram or volume of a parallelepiped. These are the three concepts that we'll be talking about in this lesson, okay? Cramer's rule, adjoint matrix, and then finding area of a parallelogram or volume of a parallelepiped using the determinant. So first thing first, Cramer's rule is a method of solving a system of equation. Guys, you already know how to solve a system of equation in high school. And we learn another method at the beginning of this course by changing the given system into echelon form. Given system, we put that in a matrix, augmented matrix, and then we change it into echelon form and we solve the system. That's another method we already learned. And today we will learn new method. Oh, by the way, we learn another method as well. So when we have AX equals B, then X can be written as A inverse B. So we already learned so many methods, right? This method is another method we learn. And today we learn another method to solve the system. And that is what we call Cramer's rule. And here is the formula. Xi equals determinant of AIB over determinant of A. I represent 1, 2, all the way up to n. Now, what does that mean? Let's look at this example 1. Use Cramer's rule to solve the system. So first of all, let me just write it down. The system is, what is given here is 3x1 minus 2x2 equals 6 and negative 5x1 plus 4x2 equals 8. Okay, you know how to solve it. That's not the question. The question is, what is the Cramer's rule? So we're going to use the Cramer's rule to solve this system, okay? So according to the formula is this. Cramer's rule is x1 equals a1b over a, or determinant, sorry, I forgot to write the determinant, okay? So determinant of a sub 1b over determinant of a, and x2 equals determinant of a sub 2b and determinant of a. That is the formula that you need to memorize, okay? That's what the formula here is. Now, what is a? What is a1, a sub 1b? So where a equals, you see, a equals, just write down the coefficient. A is actually the coefficient matrix, okay? So the coefficient matrix is 3, -2, -5, and 4. That is how we represent A, okay? A is the coefficient matrix. Coefficient matrix A. And what is A sub 1b? Listen very carefully, guys, okay? Listen very carefully. This means you replace the first column by the constant b. So this is your b column here. So replace the first column by the constant, which is 6 and 8. And the second column will be the same, which is -2 and 4. Just write it down, -2 and 4. This is called A sub 1b. Okay, this is how we denote. A sub 1b represent this matrix. And what is A sub 2b? It means you replace the second column by the constant b. So the first column will remain the same. So 3 and -5 will remain the same. Now the second column, write down the constant b, which is 6 and 8. Any question here? That's all you need to remember here. So A sub 1 means you replace the first column by B, but B represent the constant term in the system, and just write down other second column as it is from the coefficient and so on here. Now all we need to do is we need to find the determinant of A, which is, you can find it easily. So that's going to be 12 minus 10, which is 2, and this guy is determinant of A sub 1b equals 24 minus plus 16, which is 40, and determinant of A to b equals 24 minus plus 30, which is 54. Now your x1 is going to be, the formula is x1 is determinant of A sub 1b over determinant of A, which is 40 divided by 2, that's going to give me 20, and x2 equals, the formula is determinant of A to b over determinant of A, which is 54 over 2, that's going to give me 27. Done. This is all about Cramer's rule. Do you have any question? So we got x1 is 20 and x2 is 27 using the Cramer's rule. And now we will try to solve a bigger system. Let's go all the way down to example 4 in your handout. So here we will solve part A. Part B, we'll keep it, we'll do it later after a few minutes, okay? Let's try solving the system by using Cramer's rule. Let's focus our attention on part A. So to use the Cramer's rule, to solve system of equation, so all we need to do is, first of all, we need to write down what is A here. Remember the formula. Formula is xi equals determinant of A sub ib over determinant of A, where determinant of A is the coefficient matrix and determinant of A sub ib represent, I think we discussed that and we'll discuss in a minute. So A means coefficient matrix. You can write it down easily, which is 5, 2, 4. They are the coefficient of x1. Now coefficient of x2 is -2, 3, and -5. And coefficient of third column is 3, -5, and 6. This is matrix A. Now matrix A1B. I think if you want, you can, well, I think it's, yeah. So what it means is you replace the first column by this constant b. So you switch there and write down other things as it is. So 16, 2, and 7. Okay, I replace the first column by the constant, and the second column and third column will remain the same. So the second column is -2, 3, -5. Third column is 3, -5, and 6. If you have any question, let me know. Now A sub to B means what you do is you replace the second column. So this column, replace that by this. So first remain the same. So 5, 2, 4, it remains the same. So we just replace the second column by the constant, which is 16 to 7. And the third column will be 3, -5, and 6 as it is. So A to B is done. Now let's find A sub 3B. So this means you replace the third column by the constant. So this is your third column. So you replace that by this. So copy the first column as it is, which is 5, 2, 4. And then the second one is -2, 3, -5. Third one is 16, 2, and 7. Any questions so far? That's the main part. Now let us find the determinant of each of them. So I want you to find the determinant of A, which is 5, -2, 3, 2, 3, -5, 4, -5, and 6. You can use any method that you like. So you can expand the first row, first column, second row, second column, third row, third column, or you can use some properties and change into echelon form and convert it into echelon form means triangular form, and then you just multiply the diagonal. You can do that. I trust you guys, you can find out the determinant without any difficulty. I leave it to you. Now in the same manner, I want you to find the determinant of A sub 1b, which is 16 to 7, -2, 3, -5, 3, -5, 6 equals how much? I want you to find determinant of A sub to B, which is 5 to 4, 16 to 7, 3, -5, 6. And finally, I want you to find A sub 3B, which is 5 to 4, then -2, 3, -5, and 16 to 7. Okay, I'll wait. So you complete it, find the determinant of all of these things, and then we will apply this determinant into the formula to get the solution for this system. Okay. Okay, thank you guys. You already calculated the determinant for me. So determinant of A, all of you got -37. Since so many of you got the same answer, I trust that this is the right one because it is very difficult to get the same wrong answer. Most of you got this A sub 1b, determinant of A sub 1b as -111. Determinant of A sub 2b is -259, and determinant of A sub 3b is -185. Now we are ready to find the solution. Okay, so using Cramer's rule, using Cramer's rule, x1 is the formula is determinant of A sub 1b over determinant of A, which is -111 divided by -37, and that's gonna give me 3. That's your x1, and your x2 is determinant of A sub 2b over determinant of A, and that's going to give me -259 over -37, which is I believe 5. No, no, this x2 is 259, so that means 7. Sorry, this is 7, and x3 is determinant of A sub 3b over determinant of A equals negative 185 over negative 37, and that's gonna give me 5. Okay, now so we got this: x1 is 3, x2 is 7, x3 is 5, and you can verify yourself by substituting this value in the original equation and whether that makes sense or not. Okay, checking part I leave it to you. So checking, substitute this value in the original equation and see whether that makes sense. Any question? Okay, if you have no questions, then this is all about Cramer's rule. So I believe you'll be able to handle this Cramer's rule now to solve the system of equations. Okay.